Good morning. In the last class, we have discussed about patterns, allowances, and other related things. Today, we'll discuss about gating and risering. Then, so gating refers to those elements which are connected to the flow of molten metal from the ladle to the what mold cavity. A gating system essentially involves a pouring basin, a pouring cup, screw down, runner, ingates, and a riser. Then it is clearly shown in all the figures. So, in the figure, pouring basin, pouring cup, then screw base or screw down. Then so runner, ingate, then casting cavity, nothing but a mold cavity. In turn, it becomes a casting cavity and a riser. Then so along with this, these are all the call it as our different elements of gating system. So what are the requirements of a gating system? While designing a gating system, certain requirements is to be provided. Then the first requirement, molten metal completely filled the smallest time possible without having rise to metal temperature nor higher temperature is used. Second one, it must avoid entering of dross, slag and other materials to the mold cavity. Then it should avoid turbulence flow because tend to form dross in the mold. So it must be properly controlled in such a way that aspiration of the atmospheric air is prevented. Then casting must solidify without any shrinkage. Then should not take any erosion. Then it should ensure enough molten metal reaches the mold cavity. And at last, the gating system should be economical and easy to implement. Then and these are all the what important requirements to be considered. Then what are all the elements of gating system? Then pouring cup or pouring basin. Then so molten metal, it is not directly poured into the mold because it may erode the mold, hence it pour through pouring cup. It acts as a reservoir from which it moves smoothly into the sprue. It also able to stop the slag and dross entering the mold cavity by means of skimmer or skimmer core. It should always full, otherwise slag, dross and air may be entered into the mold cavity. Pouring basin is made machined pouring basin is made inclined at 45 degree to the horizontal. Molten metal is poured on this face such that molten metal momentum is absorbed and vortex formation is avoided. It also helps to minimize splash and turbulence and also clean molten metal into the mold cavity. Then a down sprue, then it is a channel through which the molten metal is brought into the parting plane where it enters the runner and ingates. Then so it may increase the velocity of the molten metal because the smaller cross section area at the bottom, therefore straight or cylindrical would not be at the bottom, but a low pressure area created around the metal in the sprue base of this temperature may decrease. Then sprue base or sprue well or sprue down they call it, sprue bottom they call it as. It is a wider cross section at the bottom of the sprue to reduce the momentum of the molten metal. The molten metal as it moves down the sprue gains velocity, some of which is lost in the sprue base as well, by which the mold erosion is reduced. Then runner generally located in the horizontal plane which connects the sprue to its ingates. Runner made trapezoidal in cross section. It is general practice for porous metals to cut runner in the cope and ingates in the drag. The main reason for this is to trap the dross and slag which is lighter because while it is melting lost its density and flow top always there. The amount of molten metal coming from the downstream is more than the amount flowing through the ingates to avoid entering of dross slag into the cavity. Then ingates, these are the number of small gates which receive the metal from the runner and allow it to the mold cavity. At last riser, then risers are the cavities provided on the top of the mold or at the side of the mold. Risers allow the gases, steam and air to escape from the mold cavity. But however, this riser normally used for compensation of solidification shrinkage of the casting process. Then so therefore it avoids the shrinkage and contraction of metal in the mold then. Later then there are two types of risers. One, it is a open riser, and second one, it is a top riser then. So open riser, it is open to the what it is open to the atmospheric air then. Blind riser, it is entirely covered by the molding sand. Therefore it is located either in the cope or in the drag off of the what mold then. So however then, riser, without riser you cannot able to what obtain a sound free casting or defect free casting. Therefore riser should be designed appropriately. So as we already discussed, then riser is a hole cut or molded in the cope to permit the molten metal to rise above the highest part in the casting. The riser serves a number of useful purposes. It enables to pour to see the molten metal falls into the mold cavity. If the metal does not appear in the riser, then it signifies either the metal is insufficient to fill the mold cavity, or there is some obstruction for the flow between the sprue and the riser then. The riser facilities eject the ejection of the steam, gas and air from the mold cavity as the mold is filled with the molten metal. Most important, the riser serves as a feeder to feed the molten metal into the main casting to compensation for a shrinkage. The use of several risers may be necessary in the case of an intricate or large casting with thin section. The main requirements of an effective riser are those that it must have sufficient volume, as it should be the last part of the casting to freeze them. It must completely cover the sectional thickness that requires feeding them. The fluidity of the molten metal must be adequately maintained so that the metal can be penetrate the portions of the mold cavity freezing toward the end. It should be so designed that it establishes and affects temperature gradients within the casting that the later solidifies directionally toward the riser. Then normally while designing all these factors, you have to consider them for good design of riser then. There are the different types of gating systems also. Those are top gates, parting gates and bottom gates then. Top gates, it is clearly shown in the figure. The molten metal is poured down the head or rise of the casting. Since the metal falls directly into the mold cavity, the mold should be hard and strong enough to resist erosion by dropping metal. The advantage of top gating is that since all the metal enters the casting at the top, then the hottest metal rises in the region then. As such, proper temperature gradients are formed and a directional solidification toward the riser located at the top of the casting can be achieved. The gates themselves may be made to serve as riser then. To prevent loose and drops from entering the mold cavity and to allow the metal to fall in a small stream, a large sized pouring basin may be fixed on the top of the sprue come riser then. A strainer core may also be fitted in the pouring basin for better results. In case of light casting, wedge shaped gates called wedge gates are provided. All those they are given in the picture then pencil gates are used for massive iron castings where in a minimum weight of head is desired and the slag is to be effectively checked from collecting the mold cavity. In the finger gate, a modification of the wedge gate, the metal is allowed to reach the mold in a number of streams then. And in a ring gate then also uses to core break the stream of molten metal besides directing the metal into the desired portion in the mold and the same time retaining the slag then. So all these are comes under top gating systems and different types of these top gates clearly mentioned in the picture then. Then parting gate, in the in the parting gate then the metal enters into the mold cavity at the parting surface then. Molten metal enters through the sprue and reaches the parting surface where the sprue is connected to the gate in a direction horizontal to the casting. The arrangement of providing a gate at the parting line allows the use of devices that can effectively trap any slag, dirt, or sand which passes with the metal down the sprue. Then figure shows all these then parting gating systems. Skim bob, where is a hollow or a recess in the cope to trap the slag and the foreign material in the metal. Then in the figure then also indicate the use of choke then, which serves as a restriction to control the rate of flow of the metal. Then means increase the velocity and molten metal rapidly flows into the mold. Then so a modification of the wedge, a modification of the choke can also be provided in almost all the parting gate system. Then so in the beside figure, use of skimming gate, the purpose of which is similar to that of skim bob, tapping foreign metal which are being lighter in weight than the metal can rise up through the vertical passage. In the other figure, use of a dam type pouring basin formed in the support part of the cope and strainer core. The purpose of both the dam and the strainer core is separate the impurities and refine the metal. The metal, however, must be very fluid when a strainer core is used. Then, if there is a tendency of shrinkage near the ingot, the shrink bob, as shown in figure, may be required. At the bottom of the sprue, a dry sand core is sometimes fixed to prevent the sand from getting washed away. Then, in case of large casting, molten metal flows through a common runner which is laid around the mold cavity, and the metal is uniformly distributed to the casting through a number of branch gates that to trap the slag. Then trap and other materials, slag and other materials. Another effective method is used skimmer gate with a whirlpool. The slag, due to whirlpool action, comes to the center from where it rises up to the skimming gate. All these arrangements have provided and were designed in the parting gate system. Then coming to the third major gating system, that is the bottom gate. Then in the case of bottom gate, then usually favored for large sized casting, especially those of steel, molten metal flows down the bottom of the mold cavity in the drag and enters the base of the casting. These are used to keep the turbulence of the metal at a minimum while pouring and prevent mold erosion. Metal is allowed to rise gently in the mold and around the courses. Then the disadvantage of the bottom gating systems are the metal continues to lose its heat as it is raised in the mold cavity, and by the time it reaches the riser, it becomes much cooler as much direction solidification is difficult to achieve. And another disadvantage, it is difficult to place the riser near the gate entrance where the metal is hottest. Then so however then the two types of bottom gates are shown in the figure. Then the horn gate enable the mold to made in two boxes only, thus eliminating the necessary of a cheek. Then so the pattern for this gate is rammed in the drag and later extracted by turning it out to the sand. However, then figure shows a bottom gating system using a dry sand core. Then the sprue is curved at the bottom end, form a dirt trap or slab. This type of gate also enables the mold to be made in two boxes. Bottom gating can be provided with easy in three-part mold by keeping the ingots on the parting line of the drag and middle part. A drawn type runner gate can also be used for simplicity in molding. The runner gate pattern is tapered and can be pulled into the mold cavity after the main pattern for the casting has been withdrawn. The gate is generally placed tangentially on the casting so as to impart a spinning action of the incoming metal. The spinning and whirling action tends to move the slag and thus it sent into the riser then. So these are the what important gating systems have to be designed at the time of design of casting for obtaining a sound or a defect free casting then. So then let us discuss about the what additives and binders used in the molding sand. Additives are what agents in the form of powders or liquids used in molding sand to impart certain desired properties to the mold. These are used in addition to these are used uh, the use of binders. Normally additives are what mold normally additives are added in very small quantities. Some of the additives used to add molding sand to enhance certain properties are as follows: cereal flour, it normally imparts dry strength and improve good quality. Up to 2% by weight of molding sand is added then. So then sea coal in powder form, either it is improved surface finish of the casting, added up to 8% by weight. Pitch then, it is a derivative of soft coal, improves surface finish and casting. It improves hot strength, added up to 2%. Wood floor, finely ground wood powder used to minimize sand expansion and improve collapsibility, added up to 2%. Silica floor, up to what 35%, especially in steel casting. So improve hot strength, increase density, prevent metal penetration, improves improves solidification, minimize sand expansion. Then iron oxide, about 0.2 0.2 to 0.8 percentage. Fine dust of iron oxide improves hot strength. Then dextrin, then it is a vegetable origin, very fine powder, improves dry strength up to 2%. Molasses up to 10% improve edge hardness. Then boric acid and sulfur then improve surface finish and prevent metal mold reaction. All these are the advantages then. So all these are the additives added to the what molding sand. Then binders is a material which impart the necessary binding action to the sand. A binder holds the sand particles together and induce the strength and other properties to the mold. Sand, when mixed with the binder, is capable of taking a shape of the pattern and retain it. Binders are classified as organic and inorganic binders, are based on how strength is developed. For example, organic binders are linseed oil, mineral oil, whale oil, and inorganic binders are fire clay, bentonite, etc. Some of the binders are developing strength to the molds are as follows. When mixed with water, clay is used as a binder. When baked in an oven, core oil and thermosetting resin is a binder then. By passing gas, sodium silicator is a binder then. By passing carbon dioxide gas then. By air setting, resin oil is binder then. Among these binders, clay is the most widely used binder then and is available plenty in nature. Clay refers to the particle whose size is less than 20 microns. It has a very large surface area and has a very high affinity to absorb a large amount of water. Clay comes in contact with the water, becomes becomes cohesive and plastic. Clay mainly consists of silicates of alumina. Clays are classified as montmorillonite, bentonite, kaolinite, illite, and fire clay. Binders are the uh, materials added to base sand to give binding cohesion and strength to the what sand mix after ramming them. So these are related to the what principles of gating system, and binders and additives are essentially required to improve the properties to uh, uh, properties of the molding sand or to enhance the properties of the molding sand. All these are essential things and very important for the examination point of view. Thank you. 19